All right, this is Honors Algebra 2 Pre-Calc. We are doing 8.4 in Algebra 2, and this is our third video, which somehow mysteriously does not exist originally on YouTube, so I am re-recording it. So, yeah, let's do this, some trickier problems. All right, so we're going to fully simplify this expression. So the trick here, there's a couple different tricks going on, right? But the first thing here is that both of these are secretly over 1, so what I want to do is get a common denominator here, right? So I'm going to multiply the 2x squared by an x plus 2 to get that over an x plus 2. Multiply this negative 1 by an x plus 2 to get this over an x plus 2. And then the other big trick here is to realize that this negative goes to both of the terms up here. This is like an x minus 1 in parentheses, so it's going to be a negative x plus 1 on top of that x plus 2. So now all of these have the same denominator, and we can go ahead and clean them up. So this is a 2x cubed, right, plus a 4x squared, because I'll distribute this guy, a minus x minus 2, and a minus x plus 1, all over this x plus 2. So I seem to get a 2x cubed plus a 4x squared minus a 2x minus a 1 over an x plus 2. And I can try and factor the top if I want. The only factor on the top that would actually make a difference in terms of me simplifying would be if the top had x plus 2 as a factor. If it doesn't have an x plus 2 as a factor, it doesn't really impact me. And I'm going to argue it doesn't, because based on the rational roots theorem, any rational root would have to have these factors, factors of 1, on top of these factors, factors of 2, and 1 over anything is not going to give you a 2. So I'm going to argue that that's my final answer. Go ahead and give this one a try. Same basic idea. Remember, this is over 1. So go ahead and pause me if you want to try it on your own. I'm going to go ahead and get a common denominator by multiplying by 3x minus 5 on the top and bottom. So I'm going to get 3x cubed minus 5x squared plus a 2x over a 3x minus 5, and that answer is totally fine. If I want to factor and see if something can come out of this, I could try factoring that and taking an x out, and then I am going to get a quadratic trinomial that I might be able to factor. And we can see if one of the factors cancels, but here's the argument I have. Even if I factor out the top, again, I can see that this is not going to have a 5 as one of the back terms, so there's no way that 3x minus 5 cancels. So this answer would also be fine. If you wanted to keep factoring, you certainly could. You could make this a 3x and an x. This would be a minus 2 and a minus 1. So this answer is also totally fine. But again, all 3 of those box answers would be fine, and none of them simplifies more than that. So there you have it. All right, so when we look at one like this, right, it's a little bit tricky. I would suggest that the first thing you do is deal with simplifying this ugly thing, and you just let this guy chill until you're done, right? So this is an x plus 2 over an x plus 5, and then I'm dividing by this fraction. So when I divide by a fraction, I flip and make it multiplication, right? So that's what's going to happen there. And again, I'm just going to leave this thing to chill. I'm not even touching it, but I do need to make sure I keep it, because this entire expression includes that 1 over x plus 1, and if I get rid of it, then it's not the entire expression. So I noticed that I could, since this is actually fully factored and multiplication, I could cancel an x plus 5, right? So these can be canceled, and I get x plus 2 over x minus 1 plus a 1 over x plus 1 rather, and now I can get a common denominator, right? Now I can simplify this by multiplying this guy by the other fraction's denominator and multiplying this guy by the other fraction's denominator. Bring this up here. So when I FOIL, I'm going to get x squared plus 3x plus 2 plus an x minus 1 all over this x plus 1, x minus 1, which I can either leave like that, or I could make it an x squared minus 1, right? If I want to make that my denominator, it's a difference of squares. The top seems to be x squared plus 4x plus 1, which is prime. That doesn't factor. So I can either leave it with the denominator factored, right? This is a great answer. Or I could leave it with the denominator FOILed out, which is also a great answer. It doesn't really matter. Both of them would count as fully simplified. They're just different fully simplified ways to write something. All right, you can go ahead and try this. It's the same idea. Certainly pause me if you don't want me to do it. So I'm going to get started, but go ahead and give it a try first. So again, I would deal with this first, and I would just leave this to chill, right? So this is a 4 over an x plus 2, but then I'm dividing by a fraction. So I'm going to flip and make it multiplication, which is not exactly the result we got last time, which is what we kind of wanted, was something conveniently canceled, right? So I seem to get a 12 over an x plus 2 quantity squared minus a 3 over an x plus 2. Well, these two fractions already have one factor in common. They both have the x plus 2 in the denominator. It's just that this fraction needs another x plus 2. Sorry, that's my bad. That's an x plus 2. So if I bring this up here, I have a 12 minus 3x minus 6 all over an x plus 2 quantity squared. Or you could FOIL it out, or you could leave it as x plus 2 times x plus 2. So I get a negative 3x plus 12 over x plus 2 quantity squared. And that answer's great. There's a couple other options, right? I could factor a negative 3 out of the top if you want. I mean, that's fine. I could leave the bottom as this quantity squared, or I could write it as this. That answer's totally fine. I could also FOIL out the bottom. Any of these answers would be equivalent and totally fine, right? If I FOIL out the bottom, I get this. So any combination of those numerators and denominators would be fine. All right, last example. All right, so we're asked to fully simplify this expression. So this is pretty ugly looking. There are a couple ways to deal with this, and one of the things I want to preface this with is that both options are right. It's just that I find one of them much, much easier. So it's not wrong if you want, okay, so it would be okay to recognize that all those negative exponents on the bottom are on the bottoms of their own little fractions. Like this is a 1 over a squared plus a 2 over ab plus a 1 over b. Like this is okay, right? So this is okay, but it's going to make it a tough path, right? Like for having a better way to say it, it's going to make it a little bit of a difficult path. Because you could get a bunch of common denominators, right? Like you'd get common denominators, and then you'd end up flipping stuff over, and it's fine, and we can walk through that in a sec, but there is a shorter option, okay? So, and I'm going to do the shorter option first, and then I can walk you through the longer one. What I can do is I can recognize that if I multiplied the entire top and bottom by a squared over b squared, it's going to take care of all of my negative exponents. So if I multiply the entire top by a squared over b squared, I'm going to get a squared b, or sorry, not a squared over b squared, just a squared b squared. A squared b squared over a squared, which we'll deal with in a sec, minus a squared b squared over b squared. Okay, on the bottom, I'm going to get an a squared b squared a to the negative second, which we'll deal with in a sec, plus a 2a to the negative first, b to the negative first, a squared b squared. Again, I promise it's going to get better in a second. Plus an a squared b to the negative second. Okay, so a cool thing is going to happen here. These a squareds are going to cancel. These b squareds are going to cancel. So my top is just going to be b squared minus a squared, okay? I'm going to just separate this a little bit. On the bottom, the a squared and the a to the negative second are going to be gone, so I'm just going to get a b squared here. The a to the negative first and a to the second will just give me an a, so this will be a 2a, right? Same thing with the b's, right? I'm going to get a positive b to the first. And then here, these two are going to conveniently be a b to the 0, so I get a plus a squared. Well, that denominator is a perfect square trinomial, and that numerator is a difference of squares. This is b plus a over, times b minus a over a b plus a times another b plus a, meaning one of the b plus a's cancels, and I get a final answer of b minus a over b plus a. Now, you might think, oh, okay, that was still pretty awful, and that was the fast way. Yeah, that's true. It was pretty hard, and that was the faster option for how to do that. So that's fun. So if we try it the long way, right? So here's the longer way, and you don't have to do it the long way. You can totally skip over this section of the video. I would not pick this, okay? So this would not be my option. I just wanted to show you that it also works, okay? So if I were going to do the long way, right, I had 1 over a squared minus 1 over b squared. So I would rewrite this as I showed you originally, like this. All right. So to get a common denominator, I would recognize that the thing all of the denominators seem to have in common is 2 a's and 2 b's at some point. And so this thing is missing a b squared over b squared. This thing is missing one of the a's and one of the b's. This thing is missing an a squared and an a squared. I'd have to multiply this guy by a squared, and I'd have to multiply this guy by b squared and b squared. So what's going to happen is I'm going to get b squared minus a squared on top of my a squared, b squared common denominator. On the bottom, I'm going to get b squared plus 2ab plus a squared on top of my new common denominator, a squared, b squared. When I divide a fraction by a fraction, so when I divide this top thing by this, I flip to make it multiplication. So the top would say b squared minus a squared over this a squared, b squared. But the bottom would become a squared, b squared on top over this monstrosity. What you might have noticed at some point is that I'm ending up in the same place I started originally, because since this is all multiplication, I'm getting this b squared minus a squared on top of this perfect square trinomial, and then it's going to factor the same, right? This is still going to be b plus a times b minus a. On the bottom, it's going to be a b plus a times another b plus a. One of them cancels, and I get the same answer. So I've done a lot of these problems, more than you probably ever will, just because, you know, high school math, totally my whole job. So I know that when I see a problem that looks like this, if I see a's to the negative seconds and b's to the negative seconds, I can get rid of an a to the negative second by multiplying by an a squared. So I do a squared over a squared. I did the same thing with b squared over b squared. Again, something I know because I've seen this problem a lot. Not everybody's going to know that, and that's okay. All right. Last one, same idea. Again, there's two ways to do this. I think the faster way is to note that shortcut. So you can pause me if you want. I'm going to go ahead and do it both ways real quick for you. So the shortcut is to multiply by the thing that would get rid of an x to the negative first and the thing that would get rid of a y to the negative first, which is x to the first, y to the first over x to the first, y to the first. If we do that, okay, so if I multiply by xy over xy, when I distribute, I'm going to get x squared y minus xy squared, right? Over, well, the x times the x to the negative first is going to be gone, so I just get a y. And actually, interestingly enough, you probably didn't even have to distribute this. I kind of slightly regret that. I would probably leave it like this. This was probably better. Leave it like this, not this. So I get x times x to the negative first, which just gives me the y. And then when I do the xy times the y to the negative first, I just get the x. Well, now it looks like what I have is on top xy times x minus y, sorry. And on the bottom, I have a y minus x. Well, when you look at these two factors, they're not the same factor, right? So they're not the same. What they are is off by a negative. Because if you think about it this way, if I do 5 minus 2, I get 3. But if I do 2 minus 5, I get negative 3. That's not an accident. When you reverse the order of subtraction, you get the opposite sign. So what I can do is I can leave this x minus y on the top, but on the bottom, I could factor out a negative 1, and what I would have is an x minus y as well. These cancel, and I get negative xy. Now, that's the shorter way, right? The slightly longer way, or just a slightly different way, if you feel more comfortable with it, we have x minus y on the top. This is actually a 1 over x minus a 1 over y, and I could get a common denominator on the bottom, right? I'd multiply by y over y and x over x, so I would get x minus y on the top. On the bottom, I get y minus x on top of this new common denominator. So now I have an x minus y, technically over 1, times the reciprocal of that. And now I find myself in basically the same spot, where I have an x minus y times an xy, and on the bottom I have a negative 1 times that x minus y. They cancel, and again I get a negative xy. And that's it for this video.